Rachel.
I'm Dixie, and we built a hovercraft for our physics project.
Hooray.
So our first one was a bust. The shower liner that we bought was just way too thin, so we bought a shower curtain it's just a lot sturdier. And yeah. So first on our hovercraft right over here, we were going to put a chair on it. We didn't really do that because that set off the equilibrium. This way we maintained more of a stable, low center of gravity so we can control it more. So now all we do is really sit on it, but that works all the same.
One of our first concepts is pressure equilibrium, which reflects on Newton's third law. The pressure equilibrium is pressure equals force divided by area. In order for the hovercraft to remain or make a force strong enough for the platform to rise, it has to have equal pressure underneath. If we are exerting 578 newtons on a 16 meter square surface, which is 36.12 pressure, we need to exert the same amount underneath to make the pressure rise.
Alright, so our next concept is friction. The air bubble underneath this hovercraft right over here, it creates a frictionless surface, which allows us to move with one single push, and allows us to keep moving, which is Newton's first law. So right now we're going to demonstrate that with Rachel.
The next concept is momentum. So, by having the weight of the hovercraft plus us and the speed of the hovercraft, we can calculate momentum. So, in our instance, 59 kilograms multiplied by 2 meters per second would give us 118 kilograms meters per second, which is our momentum of our hovercraft while we're riding it.
So the next concept is Newton's second law. It's extremely important because the force that's exerted can be calculated by mass multiplied by acceleration. When the hovercraft is turned off, it takes more force to move it. Meanwhile, if the hovercraft is on, then it takes less force due to Newton's second law. So, in this force diagram that shows Newton's second law, our forces are Earth, the force of air, and the force of the push. So in the little stick figure diagram, you can see that the hovercraft is kind of off the ground, and the force is going in that direction. Down below on the force diagram, you can see that the force of Earth and the force of the air is equal, and the other force is what is being pushed.
So, finally, the watts used in the leaf blower are the amount of power and force used to make the hovercraft elevate. So, without the watts, the leaf blower would not be able to lift the hovercraft. So, we are using this lovely leaf blower, which has about 230 watts, and it's enough force to lift me and the hovercraft and go forward. Unlike Miss Peters' prediction, there is torque in our hovercraft, and because of the circular motion, it travels in a circle just very, very slowly.